We'll start in 1 minute. We'll continue with graphing quadratic functions from Chapter 9, Section 6. So we got to this problem yesterday. So we started out with a quadratic function in standard form, y equals x squared minus 6x plus 8. We use the vertex formula. The x-coordinate of the vertex is 3. To find the y-coordinate, you replace x in the function with 3 and do the arithmetic. So the vertex is the ordered pair 3, negative 1. To find the y-intercept, just replace x with 0, and we get the y-intercept 0, 8. The x-intercepts, replace y with 0 and solve the quadratic equation. So we were able to solve this quadratic equation by factoring. And the x-intercepts are the ordered pairs 2, 0 and 4, 0. So with all of that information, we can sketch a graph of the parabola. So the vertex is the ordered pair 3, negative 1. The parabola opens upward. The x-intercepts are at 2, 0 and 4, 0. So 2, 0 and 4, 0. The y-intercept is 0, 8. So 0, 8. By symmetry, remember the vertical line of symmetry. This vertical line of symmetry is x equals 3. So we can find another point on the right side of the line of symmetry by noting that the ordered pair 0, 8 is a point on the graph. So by symmetry, we can plot another point. This point is symmetric with respect to the point 0, 8 across the line of symmetry. So this ordered pair is 6, 8. So just one other thing about these 2 points that are symmetric to each other with respect to the line of symmetry. From the line of symmetry, the point 0, 8 is 3 units to the left. And from the line of symmetry, this point is 3 units to the right. Symmetry means, in this case, it means the distance from this point to the vertical line of symmetry is the same as the distance from this point to the vertical line of symmetry. The x-intercepts are also, whenever you have 2 x-intercepts, they are symmetric to each other with respect to the vertical line of symmetry. So those little details can help you in general. Okay, let's do the next one. Y equals x squared plus 4x plus 5. Okay, work on that for a minute or two on your own. Find the vertex, the x and y intercepts if there are any, and find the line of symmetry. Okay, what did you find? We can find the vertex. The x coordinate of the vertex formula is negative b over 2a. So the x coordinate is negative 4 over 2 times 1, or x equals negative 2. And then the y coordinate, when x is negative 2, replace every x with negative 2. So we get negative 2 squared is 4. And then plus 4 times negative 2 is minus 8. And then plus 5. Negative 4 plus 5 is negative 1. Whoops, sorry, positive 1. 4 minus 8 is negative 4. Negative 4 plus 5 is positive 1. So the vertex is the ordered pair negative 2 for x and 1 for y. Okay, so that tells us something about the x-intercepts. The parabola opens upward, and the vertex is above the x-axis. So there are no x-intercepts. Another way to find or to determine that there are no x-intercepts is to use the ordinary method to find the x-intercepts. Replace y with 0 and solve for x. So let's do that. Find the x-intercepts. The procedure is replace y with 0 and solve the quadratic equation for x. X0 equals x squared plus 4x plus 5. And if we use the quadratic formula, we get x equals negative 4 plus and minus the square root of 4 to the second minus 4 times 1 times 5, all divided by 2 times 1. And then x equals -4 plus and minus the square root of some number, all divided by 2. So inside the square root, we have 16 minus 20, which is -4. So since these x values are not real numbers, that means that the parabola has no x-intercepts. Okay, so we have two methods for finding or for determining how many x-intercepts there are. The first method I'll mention again, if we know where the vertex is, and we automatically know whether the parabola opens upward or downward, then we know how many x-intercepts there are. The other way is replace y with 0, solve the quadratic equation for x, and the solutions to that equation tell us how many x-intercepts there are. So in this case, no x-intercepts. The y-intercept, every quadratic function has a y-intercept. So the x-coordinate is 0, so to find the y-intercept, replace x with 0, and we get y equals 5 for the y-intercept. Well, I'll squeeze in a graph here. -2, 1 is the vertex. The y-intercept is 0, 5. So let's find one more point on the graph. We know where the vertex is, and we know where the y-intercept is, so we can use symmetry to find another point. So tell me what another point is by using symmetry, using the fact that the vertex is the ordered pair -2, 1, and the y-intercept is 0, 5.
Would it be -4, 5?
Yeah, -4 for x and +5 for y. So by symmetry, if we move 2 units to the left of x equals -2 to -4, and then the y-coordinate is 5, so -4, 5. This point is symmetric to this point, 0, 5. They are symmetric with respect to the vertical line of symmetry. So that's a rough sketch of the graph. Another method for plotting points that I mentioned yesterday So a strategy that I often use, not always, but if I can find the vertex, we should always be able to find the vertex because the x-coordinate of the vertex is -b/2a. So the vertex is the ordered pair -2, 1. So if I pick my x value, my middle x value to be -2, and then I'll pick two x values that are smaller than -2, like -3 and negative 4. And then I'll pick two x values that are bigger than negative 2, negative 1 and 0. When x is 0, that's always an easy ordered pair to find. When x is 0, the y-coordinate is 5. By symmetry, since 0, 5 is a point on the graph, so should negative 4, 5 be a point on the graph. Because x equals negative 2 is the vertical line of symmetry. Then if you want to find the y values that correspond to negative 1 and negative 3, those two y values have to be the same because of symmetry. So if we replace x with negative 1 in the function, so when x is negative 1, the y value is negative 1 squared, which is positive 1, plus 4 times negative 1 is negative 4, so we have 1 minus 4 and then plus 5. So 1 minus 4 is negative 3, negative 3 plus 5 is positive 2. Okay, so the y-coordinate that goes with negative 1, x equals negative 1 is 2, and by symmetry, the y-coordinate that goes with x equals negative 3 is also 2. So that even looks believable on our graph. When x is negative 3, the y-coordinate is 2. So negative 3, 2. And when x is negative 1, the y-coordinate is 2 also. Okay, let's try the next one. Y equals 2x squared minus 12x plus 18. So take a minute or two to work on that one. Hey, what did you come up with? Well, let's find the vertex first. So the x-coordinate is negative b over 2a. So the negative of negative 12 over 2 times 2, or 12 divided by 4 is 3. And then the y-coordinate of the vertex, replace x with 3. So 2 times 3 squared is 18, minus 12 times 3 is 18 minus 36, which is negative 18, and negative 18 plus 18 is 0. So the vertex is the ordered pair 3, 0. Well, that tells us something. So if the vertex is 3, 0, then what else do we know? Does anybody on YouTube know the answer? If the vertex is the ordered pair 3, 0, so this vertex is on the x-axis. So that means there's only one x-intercept, which is the same point as the vertex. Let's find the y-intercept. The y-intercept, every quadratic function has a y-intercept. When x is 0, the y-coordinate of the y-intercept is 18. So 0, 18. So that'll be off the grid probably. Suppose you don't catch the fact that since the vertex is on the x-axis, that it's also an x-intercept. Well, you just go through the procedure to find the x-intercepts. Find x-intercepts. You do that by replacing y with 0 and solving the quadratic equation. So replace y with 0. 0 equals 2x squared minus 12x plus 18. And one strategy when solving quadratic equations, since the left-hand side is now just a number 0, and every other term has a common factor of 2, we can get rid of some of the clutter that's in the way if we divide every term on both sides by 2. So divide every term on both sides by 2, we get 0 equals x squared minus 6x plus 9. And we can solve this by factoring. This is a perfect square trinomial. The two factors are x minus 3 and x minus 3. So this tells us that there's just one x-intercept, which is when x is 3. Okay, that's the same point as the vertex. To find some other points, let's use the method that I've described. The x-coordinate of the vertex is 3. the y-coordinate is 0. So if I pick two x values smaller than 3, like 2 and 1, and then the next two x values bigger than 3, like 4 and 5, then we can find 5 ordered pairs altogether, which includes the vertex. So let's start with x equals 1. When x is 1, the y-coordinate is 2 times 1 squared, which is 2. 2 minus 12 times 1, so that's 2 minus 12 is negative 10. And negative 10 plus 18 is 8. Okay, by symmetry, what do we know?
Will also have the Y-intercept of 8.
Yeah, by symmetry, when x is 5, the y-coordinate should be 8 also. By symmetry. And you can verify, if you don't trust that, you can just replace x with 5. That's not too hard to do. 5 squared is 25. 2 times 25 is 50. 50 minus 12 times 5 is 50 minus 60, which is negative 10. Negative 10 plus 18 is 8. Okay, then when x is 2, what's the y-coordinate?
2.
Okay, when x is 2, 2 times 2 squared is 2 times 4, or 8. 8 minus 12 times 2, 8 minus 24 is negative 16. Negative 16 plus 18 is 2. And by symmetry, the y-coordinate that goes with 4 is also 2. Okay, so we can plot these points. So the vertex is off the grid, or not the vertex, the y-intercept is off the grid. So 1, 8, 2, 2, 3, 0, 4, 2, and 5, 8. Okay, let's try the next one. So work on the next one for a couple of minutes. Y equals 2x squared minus 20x plus 48. Hey, all done? Okay, so let's find the vertex. So x is negative b over 2a. So the negative of negative 20 over 2 times 2. So 20 divided by 4 is 5. And the y-coordinate, when x is 5, 2 times 5 squared is 50. 50 minus 100 is negative 50. Negative 50 plus 48 is negative 2. So the vertex is 5, negative 2. Is that what you got? The y-intercept, when x is 0, the y-coordinate is 48. So that will be off the grid. And what about x-intercepts? Replace y with 0, solve for x. So when we replace y with 0, we get 0 equals 2x squared minus 20x plus 48. And let's get rid of some of the clutter by dividing every term on both sides by 2. So we get 0 equals x squared minus 10x plus 24. And this factors pretty nicely. You can always use the quadratic formula if you want, but the two factors are x minus 4 times x minus 6. And so the x-intercepts are the ordered pairs 4, 0 and 6, 0. So we can plot 3 points, the vertex 5, negative 2, and the x-intercepts 4, 0 and 6, 0. Here the vertex 5, negative 2. One x-intercept is 4, 0. The other x-intercept is 6, 0. So this is, we can sketch the graph with 3 points. You can plot more points if you want to, but that pretty much tells us what we want to know about the parabola. Okay, let's look at the next page. So this time we have a leading coefficient that is negative, y equals negative x squared plus 8x minus 12. Okay, so let's go through this one, and then for the next ones after this, I'll let you work on them for a couple of minutes. But for this one, the vertex, the formula for the x-coordinate of the vertex is negative b over 2a. So negative 8 divided by 2 times negative 1, which is negative 2. So the x-coordinate of the vertex is positive 4. And then the y-coordinate we find by replacing x with 4. So negative 4 squared is negative 16, plus 8 times 4 is plus 32. So negative 16 plus 32 is 16. 16 minus 12 is 4. So the vertex is the ordered pair 4, 4. So note that the vertex 4, 4 is above the x-axis. The parabola opens downward, so we're going to have two x-intercepts. So we'll find the x-intercepts in a minute. We might as well find the y-intercept. Since that's always easy to do, replace x with 0. And the y-coordinate of the y-intercept is negative 12. Okay, let's find the x-intercepts. We always use the same method to find the x-intercepts. Replace y with 0 and solve for x. So replace y with 0, we get 0 equals negative x squared plus 8x minus 12. So we can use the quadratic formula. One thing that I've mentioned before, when solving a quadratic equation with a lead coefficient that's negative, we can divide every term on both sides of this equation by negative 1, so that we'll get a quadratic equation with a leading coefficient that's positive. So usually that makes the arithmetic easier. So I'm going to divide every term on both sides by negative 1. 0 divided by negative 1 is 0. And then negative x squared divided by negative 1 is x squared. Plus 8x divided by negative 1, we write minus 8x. And minus 12 divided by negative 1 means we write plus 12. So we can solve this quadratic equation by factoring. One factor is x minus 2, and the other one is x minus 6. So the x-intercepts, one x-intercept is the ordered pair 2, 0. The other x-intercept is the ordered pair 6, 0. Okay, so we know the vertex and the two x-intercepts. The y-intercept is 0, negative 12. That's pretty far down on the grid, so okay, the vertex 4, 4. One x-intercept is 2, 0. The other x-intercept is 6, 0. And the y-intercept (0, negative 12). So by symmetry, we can find the point on the graph that is symmetric to the y-intercept, 0, negative 12. So that will be the ordered pair 8, negative 12. So there's the parabola, roughly. Okay, take a minute or two to work on the next one. Y equals negative 2x squared minus 8x minus 10. Okay, there's just 2 or 3 minutes left. So the vertex negative v over 2a. So the negative of negative 8 divided by 2 times negative 2. So we get 8 divided by negative 4, which is negative 2. And the y-coordinate when x is negative 2. Negative 2 squared is 4. Negative 2 times 4 is negative 8. Minus 8 times negative 2 is plus 16. So negative 8 plus 16 is 8. 8 minus 10 is negative 2. So the vertex is the ordered pair negative 2, negative 2. Is that what you got? The y-intercept, when x is 0, the y-coordinate is 10, or sorry, negative 10. And then to find the x-intercepts, or are there any x-intercepts? Yeah, there are no x-intercepts. How do we know? The vertex is below the x-axis, and the parabola opens down, so there are no x-intercepts. If you didn't notice that, you could just follow the procedure, replace y with 0, and then solve the quadratic equation. But you would find that the solutions are non-real. Okay, so we should find at least a couple more points. We can put the vertex in the middle. When x is negative 2, the y-coordinate is negative 2. We do have the y-intercept, 0, negative 10. So since we're running out of time, we can find a third point using symmetry. Maybe I should have put 0 on this side. And anyway, the point that we're looking for is -4, -10. So we're out of time. -2, -2. 0, -10. And -4, -10. Okay, that's all for today. Tomorrow we'll be in the next section.